And then I'm going to start sharing my screen. And before I go and flip my screen over the notes to do the constructions, if you notice, I've got the textbook open. Has anybody started looking at any of those homework problems? Does anybody have any questions on any of the homework problems yet?
On some of the activities.
I'm sorry, what?
I do on some of the activities.
Oh, you know what? You, darling, are a mind reader. Because after I asked about the homework, the next thing that I was going to do was I was going to ask, does anybody have any questions about the activities? Okay, and so now I've got the activities up here. Which activity did you want to look at, huh?
There's a couple from each activity.
Okay, well, let me, first of all, with this first activity, you have to draw a lot of triangles. And I'm going to ask that you please submit your drawings with your work. And so, for example, I'm going to just pick the 8, 8, and 8. You're going to, now let's do one of the ones that's different. You're going to draw 3 lines. One's going to be 7 centimeters. I'm looking at E. One's going to be 12 centimeters. One's going to be 11 centimeters. And then with your compass, you're going to copy each of them. So first I'm going to use my compass and straight edge and make sure it's straight. Use rulers, use compasses. I'm going to draw one of them, let's say the 12 centimeter one. And then from one end point, I'm going to swing an arc for the 11 centimeter one. And then from the other end point, I'm going to swing an arc for the 7 centimeter one. And they're going to meet and give me a triangle. And so for this one, I should have 4 pictures. Some make triangles, some don't. And you're asked to draw a conclusion about that. Then do not worry about the pegboard part. Cross that one out. You can skip that. And don't worry about the partner questions until the very end. And we'll get to that in a minute. This next one, again, you're going to use your compass and straight edge to draw carefully. First, you're going to, with your compass, construct a segment of length EC. Then you're going to, at one end point, construct an angle congruent to angle C. Then off of that, you're going to construct a segment congruent to AC, and you're going to make a triangle out of it. Then the next one, batch, you're going to here draw 3 triangles. You're going to, with your compass, construct segment AT. At one end, you're going to copy angle A. At the other end, you're going to copy angle T, and you should get a triangle. For these, you're going to, you don't need a compass. You're going to use a ruler and a protractor to try to draw those ones. And now this one, similar triangles. I will upload my diagrams and be your partner. And so I'll upload my into Blackboard, and I will actually, I'll upload them into Blackboard, and I'll also email them to everybody so that you have those results to compare. Okay, now that having been said, Emily, were you the one who had questions about the activities?
Yeah.
What were you wondering about?
Okay, so number 1, for activity number 1, for 5 and 6, do we have to come up with 3 numbers for A, B, and C, or is it just 1 number per line?
Just 1 number per line. Yeah, I'm fine with that one if you just do one per line. Okay?
And for activity number 2, me and the tutor weren't sure on question number 2, like how to explain that.
Okay. Over here, do you see how I'm going to just randomly pick C? Over here, you've got segment RP. And then at P, you're going to copy angle P. And then from P, you're going to have segment PA. And so do you see how the angle is formed by the two sides? So it's the included angle. The angle is in between the two sides. And again, this should go along with what we had done in class, side angle side. The angle is between the two sides. Does that make sense, Emily?
Yeah.
All right.
Would that be the same thing then for number page 221?
Okay, are you talking about one from the textbook now?
No, activity 221.
Oh, activity 2, oh, on page 221. I apologize. Over here, this one is going to be tough to draw because we're constructing triangle BAD. We've got side A, B. We have angle A, but then you have to kind of try to figure out where to draw angle D. And so this one isn't going to be angle side angle. This one's going to be angle angle side. So that the angle was across from one of the sides. And so to say how they're related, you can probably just use the abbreviation angle angle side. And over here, describe step by step how you did it. It's tough to draw it because we don't know where to put this angle. We kind of have to slide it around until we get it to meet with side B. And so just describe the process that you used to do it.
Okay.
Okay.
Then that was all my questions.
Okay. Thank you for asking. Anybody else have any other questions on anything? If not, I am going to flip my Chromebook so I can see what it looks like from your perspective. And then I'm going to take the surface and you're getting a scenic tour of my house. Do you want to see the family's oldest pet as you're getting a scenic tour of my dining room? Ah, my extension cord might not be long enough. Let me see. And actually, I have to stop sharing for this to work. And so, no, the extension cord isn't long enough. Can you see Tweedledee the turtle? The turtle we got him before Katie started kindergarten, so he's about 27 years old. How crazy is that? I guess turtles live a long time. All right, now I wish I knew how to get that to focus more. But again, you folks all have the words written. And so we're just looking at the diagrams and doing the constructions. So hopefully once I start drawing the constructions, that'll be clear enough for you. So last class, we ended up looking at the construction to bisect an angle. Was everybody comfortable with that? We know how to take an angle and divide it into two congruent parts. Today, the first construction we're going to do is to construct a perpendicular bisector of a segment. This one's got a lot going on. Since it's perpendicular, it means we can use it to make a right angle. And since it bisects a segment, it's what we're going to use to find a midpoint of a segment. And so this one kind of does a lot of things for us. In order to find the perpendicular bisector of the segment, the first thing that we have to do, let me use a straight edge. Let me use my index card. It's just draw a segment. So I'm going to draw a segment over here. I'm going to call it A, B. Now, again, I really like these compasses because you can tighten it and notice that I can shake it all I want and the radius doesn't change. So again, if you want to borrow one of these, they are in my outside my office. And one more thing, I forgot to warn you, be careful when you put your hand in the bag because these, if you borrow one, because these are sharp, don't poke yourself. First thing we want to do is we want to take this compass and this isn't open far enough. You don't have to open it super wide, but it just has to visually be more than halfway. And so does it look like my pencil's more than, when my point is on A, it's more, my pencil's more than halfway to B? Once it's open more than halfway, I'm going to tighten my compass. And now from A, I'm going to swing an arc above the segment and below the segment. Does everybody have that part drawn? Not hearing any complaints. Now, I don't want to change the radius. I want to keep the radius the same. I'm going to pick it up and I'm going to put the point at B. And I'm going to swing the same way, an arc above and below the segment. Both those arcs have the same radius as the ones I drew around A. This time, if you notice, we've got two X's. So we have 2 points, one above and one below. And so if I go through and connect them, this point here, M, should be the middle of my segment. Let's go through and check. My segment has a length of 8 centimeters and M is exactly at 4. So I've got the middle. And if I pull out my protractor and check, do you see how I've got a perfect right angle? And so I've constructed something that's both perpendicular and goes through the middle. It's the perpendicular bisector. Pretty cool, huh? If anybody's wondering why that works, what happens when I draw these segments, they're all the same length. And since they're all the same length, I can use the relationships between those triangles to get that they gives me the perpendicular bisector. So That construction okay? Any questions? And again, this is our fourth construction. We're going to have 6 different constructions, and you are going to need to be able to do each of them. Then the next 2 constructions are both for perpendiculars. One is to construct a line perpendicular to a line through a point not on the line. And so what we need to do is we need to draw a line. I'm going to, well, I guess it's supposed to be a line. I'm going to just draw a segment though. Well, we're using the straight part. And I need a point that's not on the line. So you can put the point above, you can put the point below. It's just not on the line. And now if I want to make a perpendicular, again, perpendicular tells me that it has to meet at right angles. And so I'm going to try to, from this point, make a line that's perpendicular that intersects the other with right angles. But I'm not going to wing it. I'm not going to eyeball it. And I'm not going to use a protractor. I'm just going to use my compass and my index card, my straight edge. Looking at this picture, does it make sense that I'm going to put the point of the compass on the point? Now I'm going to open my compass a little bit further. You want to make sure that the pencil goes just beyond the line. And we're going to swing an arc that crosses the line in 2 points. So this arc has to cross the line in 2 points. And since it's in 2 points, it's important that I use both of them. At this stage of the game, just this once, you can change a radius, but I have a tendency to not change mine. So I'm going to keep my radius the same, and I'm going to put my compass on one of the 2 points and swing an arc on the opposite side of the line. And again, we said those 2 points of intersection were important. I need to use that other one. So now I'm going to put my point of my compass on that other point of intersection, and I'm going to swing another arc below. And so it's important that this arc and this arc have the same radius. Any questions so far? So the 2 arcs intersected at a point. I got my X. So I'm going to take that point and I'm going to connect it to my original point. And this line goes to the point that we wanted it to, and it should be perpendicular to that other line. So I'm going to cheat and grab my protractor and measure. And do you see how it gives me that exact 90-degree angle? And so I did get my perpendicular from the point off the line. Again, I apologize that my pen wobbled a little bit and I've got that goofy thing up above. Is everybody all right with this construction?
Yes.
Great. Then the last construction that we're going to look at is to construct a perpendicular to a line from a point on the line. Last time we wanted to be perpendicular and make sure it went through a point that was not on the line. This time we want to make sure that we're perpendicular from a point on the line. So we're going to draw a line. And we can pick a point anywhere on the line. Does it make sense that I'm going to start by putting my compass on that point? Again, I want to make sure my compass is tight. I don't want it to move. I'm going to put my compass on that point. And now this time I'm going to swing from that same point 2 arcs. One on one side and one on the other side. I guess if you wanted to, you could go all the way around and do that full circle, but we only need the part of the circle that crosses the 2 lines. Now, it had to cross twice, and so I need to look at both those points of intersection. If I've got to cross twice, I need both the points of intersection. But before I do that, what I have to do is I have to take my compass and open it a little bit wider. So now I've got a slightly larger radius. And from this point of intersection, I'm going to swing with that radius above and below the line. Now, this is where you have to make sure your compass does not change radius. You have to make sure your compass is fixed. And with that exact same radius, I'm going to go over to that second point and do the same thing. Swing above and below. And do you notice? Now we've got 2 points of intersection, 2 X's, one here and one here. And so what we want to do is connect those 2 points. And when we connect those 2 points, do you notice your line goes through that point that we started with? And if I compare it to the corner of my index card, do you see what I've got there is a perfect right angle? And so I've got that perpendicular that goes through the point. And so we've got to be able to copy a segment construction-wise. We've got to be able to copy an angle. We've got to be able to bisect an angle. We've got to be able to bisect, come up with the midpoint of a segment. And we've got to be able to do these 2 perpendicular constructions. Everybody all right?
Yes.
And so now the fun begins. Now we're going to use those constructions, put them together to construct other things. When I took a graduate course in math history, we needed to do all sorts of constructions. We had to be able to construct, of all things, a regular pentagon, which was closely related to the construction for the golden ratio. But yeah, constructions are fun. So we want to be able to construct an altitude in a triangle. And so let's draw a triangle. Can be any size of triangle you want. Can be obtuse. It can be acute. Any triangle that you want. So let's say we've got triangle A, B, C, and I want the altitude from C to AB. And so the key part of this triangle is to remember what that word altitude means. What's special about an altitude?
It's height.
It's the height, beautiful. But if I were to draw the altitude, I'm going to take a pencil. Could it go like this? Could it go like this? Could it go like this? There's all sorts of lines I can draw from C to AB. What's special about the altitude? How do you know when you have the height in a figure? Doesn't it have to be perpendicular? Altitude needs to form right angles. And so from C, I want a perpendicular to AB. I want something from C perpendicular to AB. Well, C, is C on AB or is C off AB? I don't think C is a point on line AB. So what we've got here is a point off a line. And so we're going to do that construction that we just looked at for perpendicular to a line from a point off the line. The only difference is here the line is connected. The point is connected to the line to make a triangle. So we want a perpendicular from C to AB. And so this isn't a different construction. It's that one construction we just did. For the perpendicular from the point off the line to the line, remember we're putting our compass on the line and we're going to open it so that it goes to the other side of the line and swing an arc that crosses in two places. And then from those 2 points of intersection, we're going to swing arcs with the same radii. And when I connect that point to the X, I should have right angles. And so that should be my altitude. And so to construct an altitude, we're doing the construction for perpendicular from a point off the line. Is the altitude construction all right? If so, our next construction is a median, and the median is a segment that goes from a vertex to the midpoint of the opposite side. And so let's again start with a triangle. I'm going to draw this one. I'm going to make this one obtuse just for the heck of it. And I'll call this triangle DEF. And we want the median from D to EF. And again, we're going to start at D. And what we need to find the midpoint of EF. And so the construction that we need here is that perpendicular bisector construction, that construction that takes us to the midpoint. So again, if I'm looking for the midpoint of EF, I want to open my compass more than half of the distance for EF. From E, we'll swing an arc above and below. And right now I'm pretending the rest of that picture isn't there. I'm just looking at EF. And then for that midpoint, remember, from F, we're going to swing an arc above and below. This gives me 2 X's, 2 points. And I'm going to connect them, but with sort of a dotted line. Because I don't need the whole perpendicular bisector. I just need over here the midpoint. M is now the midpoint of EF. And so I did all that work to get the midpoint. Now for the median, I have to connect that midpoint to that opposite vertex. And so this line here is my median. And so do you see how we use that midpoint construction to draw the median? And with this other one, we use the construction for a perpendicular from a point off the line, which is all that an altitude is. How do your pictures look for these two? How'd you do? Any questions on either of these? If not, the next construction we're going to do is to construct a line parallel to a given line through a point off the line. So I'm going to hit a line. And I'm going to have a point somewhere. And actually, this is the foundation of Euclidean geometry as you know it. The idea that through this point, you should be able to make a line parallel, and you should make only one line parallel. Through a point not on a line, there exists one and only one line parallel to the given line. When I was undergraduate, I was able to take a course in non-Euclidean geometry. And in non-Euclidean geometry, you worked in 2 different worlds. One world said through this point, there is no parallel line. All lines eventually intersect somewhere. And the other one said through that point, I can make as many parallel lines as I want. And they both give you a very different perspective on life. But this idea that through this point, I can only make one line parallel to the given line is the foundation of Euclidean geometry as we know it. Now, in order to remember how to do this construction, I'm going to do a little bit of doodling off to the side, if you don't mind. whenever I picture parallel lines, can you guys see those two parallel lines that I drew? Whenever I picture parallel lines, don't you always want to put a transversal in there? And once that transversal is in there, don't I have congruent angles? And so in order to construct a parallel line, I'm going to focus on constructing congruent angles. So in order to do this construction from my point, I am going to draw with a straight edge any line that I want that goes from the point and crosses the line. And now for a parallel line at this point, I want to construct an angle congruent to the angle that I formed. And so we haven't looked at this congruent angle construction for a little while. If you remember, to construct an angle congruent to a given angle, we're going to put our point at the vertex of the angle and swing an arc that crosses both sides. Then, where we want the new angle to be, we're going to swing that same radius of the arc. Whoops. Try to make it so your compass doesn't move. Try to make it so that your radius is the same. And then again, we said that it's important that it crosses at 2 points. We're going to use both of them. But with this construction, we're going to put our compass tip at one and our pencil point at the other. And swing an arc. And now it's real important that our compass does not move. We're going to pick it up. We're going to put the point at the place where the arc we drew above the higher point crosses the line, and we're going to swing that same radius. In doing so, we got a point. And when I connect that point, this line should be parallel to my original line because I made sure that these angles are congruent. And so to construct a parallel line, you're just going to draw a random line with a straight edge through the point that intersects the given line. And that's going to be our transversal. And then we're going to construct a pair of congruent corresponding angles. I guess if you wanted to, you can make the congruent angle over here and have alternate interior angles. Either way. Now, do we have time for one more construction? This is a fun one. The last one isn't just a construction of any hexagon, it's a regular hexagon. And can anybody refresh my memory on what it means for that polygon to be regular?
have 6 sides?
Hexagon means it has 6 sides.
Equal sides.
Regular means that the sides are equal, so it's equilateral. And it also means that the angles are equal, so it's equiangular. And so we want to make a 6-sided figure where all of the sides are the same and all of the angles are the same. Oh my gosh, that sounds daunting, doesn't it? All the sides have to be the same, all the angles have to be the same. But it really isn't hard. It's kind of a fun one. What you want to do is you want to take your compass and open it to any radius and make sure it's real tight. We need this radius a lot. Once you've got your radius, you've got to keep it the same for every move we're making. I'm going to, with that radius, draw a circle. And I think I told you guys, when I was a kid, I was never good at drawing circles. I couldn't get that spinning all the way around right. And so my favorite way of drawing a circle is to actually keep the compass fixed and turn my paper. I find my circles are much more exact if I do it that way, because I am that person that has little to no hand-eye coordination. And I find it easier to turn the paper than to turn the compass. Is there anybody else in that same boat? Are you? Yeah. Spin the paper. So we've got the circle. Now look at the circle, and anywhere on the circle, pick a point. Any point you want. Now what's real important is we have to make sure that our radius did not change. But from that point, I'm going to swing an arc that crosses the circle. Then, from that point, I'm going to swing an arc that crosses the circle. And then, from that point, I'm going to swing an arc that crosses the circle. And then, from that point, I'm going to swing an arc that crosses the circle. And then, from that point, I'm going to swing an arc that crosses a circle. And if everything lined up right, when I go back to that point, I should swing an arc that crosses my original point. And now we have 6 points. 1, 2, 3, 4, 5, 6. They're equally spaced around the circle. And so when I connect them, I should get a regular hexagon. And so I think if I remember correctly, we've done it several times. Each of the angles of this hexagon should be exactly 120 degrees, and all those sides should be the same length. How cool is that? I think that one's fun to do. I've had students in the past that instead of just making those arcs, they make full circles around and it comes out looking like a flower. But when you connect those, what you get is your regular hexagon. If anybody's wondering why that works, if I were to take the center and connect it to each of those points, what we'd have here are 6 equilateral triangles. And do you remember when we were working with our shapes, we had said that the yellow hexagon was equivalent to 6 of the green equilateral triangles. So How fun is that? I honestly think that's the most fun construction. But I do enjoy doing these constructions a lot. So, looking at my watch, I've got that it's about that time. I need to, oh, I'm going to say, where did my Chromebook go? And I'm sitting and thinking, oh no, it's right here in front of me because I used my Chromebook to make sure that you guys could see what I'm drawing. So attendance wise, Jess, you want me to add you? Anybody else come to class late? Any questions? Are you guys having fun with these constructions or no?
Somewhat.
No.